Good, and welcome back to class. Thank you very much for joining us. Yes, welcome back to Mathematics with Edu-Ada. We'll be going into another topic today, and we're considering indices. So we'll just quickly talk about the laws and we'll solve questions on it. So here we go. We have the most important aspect of this is the ability to identify or to familiarize yourself with the laws, then use them to solve the questions. So let's have the laws quickly, then we'll pick an examples and we are good to go. So we have this, we have indices. What are the laws? Let me just write that here. So if you have the laws 1, let's talk about the multiplication law, such that if you have anything, okay, let me use something else. You have this same pen, so you are having to use b raised to power 4 times another b raised to power 3. So what does this show? You have, let me indicate something here quickly. In indices, you must be able to identify with a base and a power. So this b is a base and this is a power. So you can see it is power because it is like a subscript, and b is a subscript, so it is the base, or b is not actually a subscript. If you have something below b, that will give you a subscript, so b will be the one carrying this power. That's why we call it the base. So you have this. If you have something like this, don't forget I wrote 3 here. So if you have something like this, you are going to be having, okay, this is 3. So multiplication law states that since you have common base and you have their powers either common or not common, what you do is you add them up. It's not that you can't go this way to multiply through, as in multiply this out. It's possible, but it's just a long journey. So now that you have this, now we just be raised to power this. So 3 plus 4 will give us 7. So it is as straightforward as that. What does the second law state? You have the same b, or be consistent with those values I'm using, or the alphabets. Now you have raised to power 4. This multiplication, then becomes division law. So this divided by this, you have another b raised to power 3. What does this become to? Don't forget, this is division law. What does multiplication law state? You have this times this, common base. This is common base. I can equally write this as, this to power 4 over this to power 3. I'm saying the same thing as what I said. There's only thing I'm saying here. So what do? By division law, you pick this base, pick one of the bases. They are similar, they are the same thing. Pick one of them. So you have raised to power 4. Then the division law says when there are numbers, common bases, raised to power anything, dividing each other, you have pick one of the base. So you have this should be equal to b. So you have 4 minus 1 or minus 3, that gives you 1, and that is the same thing as just b. So that goes with that. Let me partition this part. So you have another law that says that if you have, let's talk about anything raised to power 0 with the exception, okay, let me make this known well. So you have b minus b raised to power of 0. What does this give you? It gives you 1. So b stands for any number with the exception of 0. Yes, 0 raised to power 0. It is not 0. It's not 0. So it's only go for every other number with the exception of 0. So that means another rule as stated there, that is 3. Then let's talk about the power rule. Yes, if you have the power law or the power rule, what do you have? You're having b raised to power 3. Then you have it again, you have another one outside. So what do we call this? Normally I call this power as connected with power, which means you have b raised to power 3, an initial power, you have another power outside, so it's just power multiplying power. So you're going to be having b raised to power 3 then times 4. And what do you have? Have b raised to power of 12. That's power law. So which implies the same, in the same vein, you can have something like this, the same vein under the same thing. You have b raised to power of 4, for example, and you have everything raised to power a fractional power. What do you do? Raised to power 3 over 2. So what do you do? Just let the powers multiply powers. Powers multiply powers. So you have 4 times, you have 3 upon 2. So what do you have here? 1, here 2. So what do you have eventually? You have b raised to power of 2 times 3, that is 6. So this settles this. Good. I'm sure you are following up. So we have, let me wipe this off. So we go to an inverse rule, the inverse law. Yes, you can have a power that is carrying. Okay, let me just write that. You have 5. The 5. So you have b raised to power of minus 1. That means this negative sign you have here form the inverse. Come 1 over b raised to power of 1. So this 1 is still the power of b, but there's a negative value the power is carrying, and that negative value is what forms this inverse. So you're going to be having still 1 over b raised to power 1 is still b. But note something, if you have something like this, x over y, you have to look for the inverse of x over y. So you don't even need to do your calculation. You don't need to do the calculation. All you have to do is to look at this. What is the inverse of b? It gave us 1 over b, right? So what's the inverse of x upon y? It will be y upon x. Yeah, you can solve that out by going the way I did this. You get the same thing. Or should we go? Okay, let's go. We have an inverse of x over y. That means 1 divided by x upon y. That is 1 divided by x over y. And what that translates into, that will translate into 1. 1 is the one dividing this. So you have 1. Let me write this in another form, so that you have this, have 1, then divided by x over y. So you can see what is here is what I'm having here. This is inverse. You can try to put this one as raised to power 1. If you put this as raised to power 1, it's still the same thing, but I need to be putting this so that in case you are having raised to power any other value here, so you have this 1, you know, your division changes to multiplication, right? And that's when it changes, you're going to be having a swap of the denominator and numerators and denominators. So you have this. So that's why your answer becomes y upon x, just like I wrote here. So rule 5 stated. Okay, let me call something an extension. Okay, or I'll call it rule 6. Let me call it rule 6. Let me call this rule 6. If you're having fractional powers, what happens now? Without any other power multiplying them something, what do? Yes, call it fractional powers. What do? So follow up. You have 6, rule 6. You have b raised to the power of 3 over 2. What happens? The b is the base, you know that. It has a fraction and has a numerator and a denominator. Now note this. This denominator will always form the root. So the value of the denominator forms the root, and the value of the denominator here in this very one is 2. So that will be second root of 3, or you call it square root of 3. So which implies that if you are having b raised to power of 3 over 4, so what do you have? You're going to be having the fourth root of b, and that will be equal to you have fourth root of b raised to power 3. Do you see that? So it is as direct and simple as you should know. So you have again, then there can be an, yes, let me bring an extension of this. You can have something like this. What if you just have a negative fractional power? You have minus 3 upon 2. So what do you have? Like I said, when you have a negative power, just make sure the negative sign, it will form the inverse. You have b raised to power of 3 over 2, and that can be equal to what is here already. So that not exactly this, it means 1 over b square root of b, then all raised to power of 3. So I think something was wrong here. So I was saying this, but actually wrote something else. So that is what you should have here, raised to power of 3. Okay, let's solve some questions quickly. Look at these examples. I have the following questions to solve. If you are having questions, you have to just work with the laws and you get the questions solved. So how do we go? You have examples. You have h raised to power 1 over 3 times 5 raised to the power of 2 over 3, then divided by 10 raised to the power of 2 divided by 3. Okay, let me do this. So we have this 2 divided by 3. You need to be very careful with this. So how do we go? So we solve. If you are solving, following the laws of indices, look at this: 8 raised to the power 1 over 3, then you have 5 raised to the power this, when you have at the denominator 10 raised to the power something. If you can express this in power of 2, which is 8, this is already in power of 5, you can express 10 in power of 2, and as a multiple product of 2 and 5, that is 10. So we can re-express them in power. So we have something like this. Okay, let me just express this straight up. You have 8 raised to power 1 over 3, that will be 2 itself, raised to power 3. That one will give us 8. Then you have 1 over 3, the initial power remains where it is. Then you have times, you have 5 raised to power 2 over 3, then everything divided by 2 times 5. Yes, 2 times 5, which is 10. We are still writing 10. Everything raised to power 2 over 3. With this power, let me rewrite it so that have this is raised to power 2 over 3. So what do we have? We have this and this to cancel out. You see that? So you are going to be having 2 raised to power 1, which is 2, then times 5 raised to power 2 upon 3, and your division comes. Don't forget, this one is carrying power. This one you can split this. 2 times 5 raised to power 2, 2 times 5 all raised to power 2 over 3. You can express this as 2 raised to power 2 over 3. That is, you will express them individually or singly. So you have 5 raised to power 2 over 3. See, you get it? So the same thing is just like a factorizing the power. Yeah, you can bring them back together. So this happens. So you have this 2 raised to power something raised to power 1. You have this raised to power 2 over 3. This raised to power 2 over 3. This raised to power 2 over 3. So since this raised to power 2 over 3, you can just cross this and this out straight. But I want to follow the laws of logarithm. Laws of indices to solve that. So you are going to be having 2 raised to power 1. There's division, right? So you have minus 2 over 3. Then times 5, 2 upon 3. Then minus, this is 2 upon 3, division here, so we have this minus, we have 2 over 3. So what do we have? What is 1 minus 2 over 3? That should give us 1 over 3. 1 is that 1 over 3. Confirm that. So we have this. This, okay, you have this, yeah. So you have it as 1 upon 3. So that's, you are good to go. So you have this here. You have that will be 2 raised to the power 1 upon 3, then times 5 raised to the power this minus this. You have 0. The same thing. So 5 raised to the power 0 is 1. So final answer becomes 2 whole number 1 over 3. That settles that. But if you have a question like this, you have this. Let me just write this for you have 64 over the square root of 125. What? Everything is raised to the power of 0. The answer just becomes 1. Simple. Everything is raised to the power of 0. So you have that sorted. Let's have more questions. Okay, let's solve this before I run this up. Solve this. So we go to example. The next example, we have this. That's something like this. We have 64. R is to the power minus 6. Everything here is raised to power 1 over 2. And this is not just a square root, it is a third root. So what we have to do is to simplify. We're told simplify. We are told to simplify this. So how do we go? Yeah, if I were you, I will re-express this third root in form of fractional power. Then I will see something. I will see a light here. So you can go different ways because you already have a square here, raised to the power 1 over 2 inside that bracket. Okay, let's do that. Let's just break down from inside. You have, let me draw a bigger one here. You have this. So you have 64 and so on. And you have R raised to the power minus 6. This will form another, this form raised to the power of minus 6. Then raised to the power 1 over 2 means another square root. This one is just a third root. So this is what the question is in another form. So you can just, if I were you, I will remove all these roots and express them in a fractional power. So I'm going to be having 64. R raised to the power 6 means times R raised to the power minus 6. Then everything, the third root will give you 1 over 3. Okay, you give you 1 over 3. Then you have it again, having raised to the power 1 over 2. That's another power here. Yes, I want to be sure. This what power of 1 over 2 is not for R, it's for everything. So you still bring down 1 2 here. 1 over 2. 1 over 2. So power law comes in here. So what do you have? You have 64 times r raised to the power of minus 6, everything raised to the power of 1 over 6. Can you see this? Then you split what is inside the bracket, split them over this power. So what do you have? You're having 64 raised to the power of 1 upon 6, then times r raised to the power of minus 6, then times again the power, which is 1 over 6. So what do you have? I can re-express this since nothing is showing here, though this means the 6th root of 64. Yes, it means the 6th root of 64. So that means I can write it, then just write it, the 6th root, because the denominator will form the roots and the numerator forms the power. So you have 64, then times this one too will form r raised to the power 1, r raised to the power minus 6, now 1 over r raised to the power 6, and everything raised to the power 1 over 6. So it means you are just having, I'm writing this again, I have this as 64, and the 6th root, then times, what do you have here? I have the 6th root also of 1 over r raised to the power of 6. So this, I will still write this. Okay, this will give me the 6th root of 64 is 2 times, here you can rewrite this as this, like we taught in indices. You can write this as in sort, taught in sort, that the 6th root of 1 divided by the 6th root of r raised to the power 6. So you split them, Abby. How will you split them? So you still have the any root of 1 is 1, so that stands. That will be 2 times 1. The 6th root of r raised to the power 6 is r. R in 6 places. So your final answer becomes 2 divided by r. That's the simplification of the whole of this to this point. So in our next video, we'll be dealing with, or in the next part of this, we'll be seeing initial equations, and we're solving it with respect to other questions that are under indices. Could lead to simultaneous equation, can lead to logarithm. So we'll talk about that in our next video. Thank you for stopping by, and please kindly subscribe to our channel. And if you want to reach us, you can reach us on our number of contacts. You can is online. Check them there for anything. Thank you very much. See you next class.